we working? Actually, might make myself a little bit bigger. I'm gonna try sitting down here today. Yeah. Oh wait, I was looking the wrong way. Yeah. Yeah. I'm gonna clean up my code from yesterday, 'cause it's pretty yucky. I started to. Yeah, I think I'll just continue doing it. Oh, I guess I didn't push my changes. Let's let Java projects wake up. Come on. Are we there? Yes. Okay. So I'm doing some crazy stuff. I don't know why I chose. I don't know what I was doing. You know, I was just kind of brute forcing it. I was tired last night. It worked though. Like, it's all like, it's just ugly and there's a lot of duplication. But aside from the duplication, I don't want to do it like this. So I'm not just going to refactor. I'm going to change how this works. So I'm going to have the directions stored in an array. So we start, you know, with the direction, with the up direction. So that's going to be one row above you, which is -1. And if we take a right turn, we're turning 90 degrees to the right every time. That'll put us going to the right. That's no change in the I. And then going down, going right or left. Wait, yeah, up, right, down, left. And then similarly with the J offset, this will be 0, right, down, left. And just so I don't I don't even want to look at my old code anymore, it's confusing. I'll look at it a little bit. Simulate, patrol. Let's just make this a void for now. So simulate the patrol. There are some things that won't really change. Just for now, I'll call it simulate. And so for finding the guard, apparently it's always going to be in the up facing position first. I think it's what it definitely said that in the instructions So I can even rewrite that. You know, it's gonna be oh. And what is this going to return? Yeah, I'll have it return. Simulate. So I wish you could do like decomposition in Java. That'd be cool, you know. And then something like that. Whoops. And we have, yeah, I made that up there, but doesn't really need to be up there. Oh. And I you know what? I'm gonna try it. I'm gonna do this differently as well. That's gonna be direction IJ. And oh, how are you gonna do this? Oh, well, it's gonna be 4 directions, M and N. Nice. And okay, I'll call it visited. It's not really a good name though, because it's like distinct visited. Well, not even that. I'm using that to like detect a cycle. Yeah. Yeah. And we just want to say while not visited. Oh yeah, direction equals 0, or direction equals, yeah, 0 is going to be up. Up, which is going to be 0. IJ. And check your indices here. Okay. Right. While not visited, direction IJ. And then all those suckers, what we're gonna do is if, let's see, the one in front of it is going to be, yeah, we'll say if how can I cleanly do this? I mean, I want to do this. I want to go if grid. I'm going to change this to direction. Grid I plus DI, oh dear, you know, J plus DJ dear equals pound. But I could get it out of bounds. Well, yeah, I could get an out of bounds there. We'll just think about how to fix that in a second. But if it's pound, we want to take a right. We just want to go deer equals deer plus 1 mod 4. That way we just cycle through the directions. So that'll cycle us through to the directions. Else we just want to move forward. We just want to move forward, so we want to say I plus equals DI deer J plus equals DJ deer. Yeah. I think marking them with the X works pretty good, so yeah, marking them with the X works pretty well. I'm going to keep marking it with the X. Yeah, if either one of them goes out of bounds, then we're off frame. That's all I got to worry about, if either one of them. So if I plus DI deer is less than 0, or, you know, basically all of them. All 4 of them. J, or this can be I still. J. Shoot. Yeah, so 0. GJ is greater than or equal to N. Okay. If that's the case, then we just want to grid ij equals x. It's basically, it's going to be this. Or this, yeah. Or not this, actually. I'll I'll clean that up. That's easy to clean up. Booleans are easy to clean up. If that, then do all this. And then else, just change the direction. Then you can get rid of this. So for out of bounds, I'll make a helper for that. Is that all I need? Yeah, there we go. Oh, and J. Then I can replace that. If out of frame or not blocked, is obstacle, and this will return this. I know it's I don't need a helper for that, but if out of frame or not an obstacle, mark this place and then go to the next place. Only thing I gotta do is visited It's true. Else do that. Yeah, that should work, right? And then what do I need to do? I should. Let's see. When would you? That's right. Yeah, right here. If visited return true, and this will return is if it's in a loop or not. That way part 2 won't change much. And then just return false out here. Oh, actually return, yeah, return false. That's not the best way to do that. Simulate. Yeah, I don't remember what the answers even were. It's almost time for day 7. What was my first answer? $50.67. Oh, it's taking a while, huh? Oh. Huh. What? How am I getting index out of bounds? Oh. Crap. Yeah, don't do that in there. That's weird. Then you don't need to pass this. Then you just need to change this to include it. And you don't need to pass that. Dang. Okay, 47. Oh yeah, check this first then. Yeah, some things are changing about this. I'm actually going to comment out part 2 since it's so dang slow right now. Okay, that works. So that's using the new... Well, let's uncomment it, see if it works. Oh, I'm actually not using the new one in here. See if that makes it any better. Perfect. It's like way faster. 1793. Yeah, way faster with the Boolean array. I'm using that. Not using this anymore. See you later. And I'm gonna get rid of that too. Get rid of that. Yeah, I got simplified a lot. Let me like reorder some stuff. Let's see, node. I'm not even using that now. Not even using that now. Not using any of this. Not using that. It's almost time for day 7. So I want to put run first, obviously, and part 1, part 2 first. Basically just put all this first. And don't need that now. I actually don't need that. Find guard. Gonna have to rename that here. Whoa. What the heck is that? Yeah, I don't need that anymore. Oh, so I'm not using... Yeah. Yeah, you don't need that part anymore. Make sure it still works. Nice. And this is like to renew the grid. Guard position. I don't like how I'm doing this. So let's clean this up. Maybe that'll help us think about that. Oh crap. I really want to finish cleaning this up. I'm actually going to call this, and then I'm going to call this temp. No, that's the, I don't know. There's got to be a better way to do that. Alright, it's definitely an improvement. I might come back to it. We gotta get to day 7. Over a river and through. Oh, over a river in the middle of the jungle. The chief isn't on his side of the bridge, though. Maybe he's on the other side. When you go across the bridge, you notice a group of engineers trying to repair it. Apparently, it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it'll take. The engineers tell you that it only needs final calibrations, but some young elephants were playing nearby and stole all the operators from their calibration equations. They could finish the calibrations if only someone could determine which test values could possibly be produced by placing any combination of operators into their calibration equations, your puzzle input. Each line represents a single equation. The test value appears before the colon on each line. It is your job to determine whether the remaining numbers can be combined with operators to produce a test value. Okay. Operators are always evaluated left to right, not according to precedence rules. Gotcha. Always left to right. Okay. Furthermore, numbers in the equations cannot be rearranged. Glancing into the jungle, you can see the elephants holding 2 different types of operators, a plus and a multiply. Only 3 of the above equations can be made true by inserting operators. Yeah. Okay. The engineers just need the total calibration result, which is the sum of the test values from just the equations that could possibly be true. In the above example, the sum of the test values for the 3 equations listed is that. Okay. Pretty straightforward. Let's grab that. Day 7 sample. I'll go ahead and grab our real one too. Nice. Let's make our class day 7. Okay. Okay. And my tests are actually broken for 6, so I'm gonna comment those out for now. I was trying to fix it before this, just ran out of time. Oops. Okay. What was that expected output? Should really just copy this over. Okay. Okay. Sir equals expected actual. Okie dokie. Great. Okay. So we need to let's just get them as lines. And then what? Unreachable code. Oh. So we got the lines, and for each one of those lines we want to, what do we care about here? We just care about the first number. So this will be the evaluation. And it's possible it's going to take result And it's also going to take a number of operators. How can I pass those? I guess those as a list too. List. Operands. So we got the lines. Whoops. Split by that. Raise dot stream that line dot what can I do here? I know, dude. And split those by white space. Okie dokie. Right. Now, is possible is going to be a little trickier. I'm actually going to have to double check this method real quick. So I just get the lines from the file for each one of those lines. I grab the result, which is the number before the colon, and I get all the operands by getting all the numbers after the colon, splitting those by space, mapping them to integers, and collecting them to a list. And then if the sum is, or if that result is possible with those operands, I'll add the result to the sum, and then return the sum. That's right? Yeah. And we're only allowed to add and multiply this for the next step here, if it's to check if it's possible, the actual hard part. So, just looking ahead here for part 2, I'm gonna try to code it kind of flexible. So, and I'm gonna make this char, and we're gonna have add or multiply. Okay. Seeing if it's possible now. We need to do said operators are evaluated left to right. So how can I do this? What is this? First of all, is it like it's gonna be combinations. So like for each operator, it should be the number of operators. This would be 3 to the end. Yeah, 3 to the end. No, wait. Yeah, 3 to the end. This would be 3 times 3 times 3 times 3. Or we have 2 operators, 2 times 2 times 2. It's basically making a binary string. Well, yeah, we are. We're making a binary string. All combinations of the operators. And we should put them between the operands. So I will make an evaluate. Evaluate. And that's going to take... What is that going to take? That's going to take the result. Well, that's just going to take the operands. It's going to take a list. Operands. Yeah, and a list of character operators. I'll call this ops. Now to evaluate, we should have operators and operands. Operators. How can we do this? Like, start, like let's say I have like 2, 3, 4, and then I have that plus and multiply. Then I could loop through, starting at the second spot on the number array, and then here, I could just get -1 this one with this guy. Or two. Oh yeah, I could just do that. So like make the first one, yeah, just make it result equals operands dot get operands dot get first, and then for int operand and operands. Actually, you want to use indices here. Equals 1, I is less than operands dot size. And it's gonna be I -1 to get the operator. So we're just gonna say result if, let's see, char operator equals ops operators dot get I -1, and then I'll do this if operator equals result times equals operands. Yeah, do this. Oh, yeah, I don't need to do that. Yeah, just result times equals operand. I'm gonna rename that. For now, I can just put an else here. Result plus equals operand, and then return that result. Evaluate. So we need to get all the combinations, all the possible, like, yeah, combinations or whatever. So we have the operands. There's just going to be one less operator, so and the number of combinations is actually going to be pretty crazy. So I think I'm going to make them as we go. So 4. How am I going to do this? Yeah, I gotta remember how to make combinations. I don't want to do it recursively. It might be, I might just want to make it recursive. It is possible. How would you? If and this is going to have list of integer operators, operands. Yeah, and we can be done. What? Hmm? Oh. Wait. Oh yeah, if evaluate equals target, then we can return true. Else, you want to return for int I is less than operators dot size, and for int j equals 0, j is going to be less than ops.length plus j, and we're going to say That seems like it'll work, but I don't know. That seems kind of a little too simple. We'll see in a second. Okay. To check if it's possible, we need to make that list of operators. So we'll just say return check combos target. This will be the operators. So we're going to say collections dot in copies. How does this work again? Okay, in copies. So in is going to be operands size -1, and we're gonna fill it with ops 0. Okay. All right. This doesn't return an immutable list, does it? It does. Oh, I do need that one. Am I missing one? What? Oh, I messed something up. Oh yeah, put this around the other way. No, it's good right there. No, it's not. What's wrong with this? Oh. There we go. We'll see. I don't know about this. Where's that? In my test? Oh yeah, for sure. Stack Overflow. Okay. So. Oh, you know what I didn't do? No, that should do it. I don't think it should Stack Overflow. What's wrong with this? I gotta feel like I'm close. Let's look at my base case. If we're there. Oh. Yeah. Target. I feel like I need this loop. Oh, you know what? Yeah, just loop with, loop over the size. I know I need to change something. This doesn't seem right either. Oh. Hmm? Oh, what happened? Oh, I forgot to change that. So this will be 0. Oh, what are you doing? So it's gonna take target, then the what the heck? Oh. What did we get? Array index out of bounds, line 33. What? Oh. Yeah, where did that happen in our code? We're on day 7. Day 7. Oh, we're not there yet. Sample. Yeah, let's see. Oh. $34.57. No. Wait, how are we evaluating it? We're evaluating it left to right. Yeah. Right? Something is wrong. let's see how many. Well, let's think about this. I want to see if I'm doing the right number of combinations here. So I'll just put like a little thing up here for a second. And let's come here real quick. And for the first one, there should be two. There should be two combinations for the first one. So let's see if that checks out. Zero. Oh. Oh, 3. How is that? Plus count. Oh, I can do this. I forgot. So 2 operators. Why is plus there 3 times? Oh. Let's see which ones. And which ones were actually right? Oh, wait. Oh, the first number, I see. Not the results. 190, that one, and that one. Oh, I'm not even getting the right numbers anyway. 3267 292. Okay. So I'm getting something wrong. How am I getting... Oh, I'm just not getting the 292 one. Wonder why that is. The 292 one is not passing. 292. Oh. So let's play with that one. There's gonna be a few of them. So there's 3 spaces in between there. Yeah, 1, 2, 3. So there should be those 27 of them. 1, 2. Well, those are the same. 4, 5, 6, 7, 8, 9, 10, 11. Oh, why am I counting these? Because I don't know how to use 1, 2, 3, 4, 5, 8, 9, 10, 11, 12. So we're not actually doing all the right. We're not doing all the combinations. I'm doing like permutation and combination or something. Yeah, I'm gonna have to change the arguments again. So it'll be like that. Should I do another one? That's not enough. That doesn't look right either. That's not right at all. Oh. That's still not right. Oh. Yeah, I'm not sure if I need that third one or not. If this is 27, that's right. Oh. Just copy it, put it in a dang file. Hmm. 36. Okay, so I think I probably don't need this third part. That didn't feel right. Yeah, I haven't done combinations with recursion in a while. Whoop. It's easier to go down, isn't it? Sure. That doesn't look like 27 either. It's not. Oh, what is it? It's supposed to be 2 times 2 times 2. Oh wait, it's supposed to be 2 times 2 times 2. It's supposed to be 8. Hold it. Wait, that doesn't even... Let's see what's going on here. It might be like this. One, two, three, 4, 5, 6. That's not right. How many did this one give me? Something is not right at all. Way too many. Yeah, it's like duplicating them, basically. Wait, am I just printing twice? So they're all doubled. Am I printing twice? No. They're printing twice though. How many are here? Let's see how many are here. Cause I have like double. They're like doubling. Yeah, those last few are the same. 8 plus 8, there should be like 16. But like these... No, I have a lot of duplicates. What's going on? So I think I have to loop through. I think I do need a for loop, man. Yeah. That's what it is. Like that, I think. Let's also go back to put that back. Stack Overflow? Yeah. I actually couldn't tell. Was that Stack Overflow? This will tell me, I think. Yeah, Stack Overflow. actually might not need that one. Wasn't this how I was doing it earlier? Yeah, we're not getting that one. So let's print these suckers out again. Just for that one. I think that's doing what I want. But there's like too many of them. Wait, what am I doing? Can you do this with a No. Hmm. What if I do this? I don't remember. Where's that set? I Oh, now we're getting it. But that's definitely not the right number of combinations. Well, I guess it's not going to go through all of them if it just finds one that works. Right? Three, 7, 4, 9. Oh, I think we got it. Finally. Takes me about an hour every time. Let's take out this print statement. Let's just run Gradle test to see. Nice. Let's run it with the real deal. Uh-oh. Dang it. String index out of bounds. 0, -1 out of bounds for length 0. I didn't put it in there. Crap.
Is it too big?
Yeah, I gotta use longs. Big number time. And might want to make these longs too. Da, 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 da. Okay. What? Oh. Okay. One more thing. It's possible. Okay. That shouldn't overflow. What the heck is all of that? What am I printing out? Oh. Boom. Big number. Let's double check that. Run our tests again. Alright. Let's try it. Dang it. My answer is too low. Answer's too low, but it passes the sample. So, yeah, I don't think I'm doing my combinations correctly still. So I gotta check on my combinations. So I'm still not doing the combinations right. I'm gonna Google it now. It's actually, I'm gonna look up this possible. No. That's not what we're looking for. Would it be a permutation? No, it's not a permutation. No. I don't want to look at... I'll look at pseudocode. It's definitely a combination. My brain doesn't work right now. Yeah, what is this? Is this a combination? I can't really remember. Yeah, it's like that. How you do that? So I could set the first operator. Well, they all start off as, I think I started them off as whatever the first operator was in there. So this is permutation. Yeah, how you do it? Just tell me. Oh, yeah, that makes sense. So you set the first operator with a times, and then you check all combinations or all permutations, and you set the first one to plus. So either you set it to times and check the rest, or you set it to plus and you check the rest. That's how you think about that. So I'm actually just gonna, those base cases are good. And I'm gonna just simplify this for now. They might add more operators, we'll find out in a second. I do want that though. So operators dot set I to plus if check combos now what am I doing? Yeah, so you just have an index to loop through. call it I. I plus 1. Oh. Turn true. And then operators dot set I to the times. I mean, there's only so many operators. I can just make more recursive calls. It's whatever. If check combos, it won't be like that ugly if they add another operator. Just to add another. Turn true. Then, I think we're missing a parenthesis. Turn false. Alright, try that. Oh! Oh. Oh, wait. That's not what you want to do. You want to do... Yeah. You should be checking... Your base case is I. Now, if I equals operators.size, then return evaluate. Operands, operators. Why doesn't it like that? Oh. Oh, that's right. Target. Yeah, that's your base case now. So 3749, that was a sample, right? Dang, I should have... That's the answer I got earlier. 194. So yeah, that's a different answer. I don't know. Dang. So this answer is too low. Let's look at those combos, or whatever they are now. Yeah, you don't want to look at all of them. Yeah, something's not right, huh? What the heck? Why is the number of them growing? That's weird, huh? Shouldn't be. Oh, that wasn't the sample. What the heck? Come on, man. Oh, crap. Real. 7 sample. That's not enough. That is not enough. Oh. No, that should be it. Yeah, that is not everything. What did I do wrong? I'm doing that, aren't I? That is weird. Yeah, it's not doing enough combinations here. What am I doing wrong here? What did they do? That's what I'm doing. Why come not work? Looks like it's gonna be another 2-hour night. Set it to a plus. Then check all the combos. Are we flipping them or something? No. That is weird. Should be printing. So we're not doing all. Is that what this one's doing? Yeah, it should be 8 like that. Well, how many is that? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, that's 8. That's what I should have. I'm mad confused. Why come this doesn't work? It's something to do. Yeah, I should see more print statements. Let's just do it by hand. I'm losing my mind. Paper. Pen. Alright. Here we go. I starts at 0. Let's do... Okay, so they're all starting as pluses, let's say. Plus, plus, plus. I starts at 0. So I'm going to draw a little tree here. Plus, plus, plus. We're going to go left. And we're going to go right. Left is going to be setting that first one to plus, which it already is. Then we have plus, plus, plus. And then from there, it's going to go plus, plus, plus. From there, it's going to go on to set that second one with a plus, which it already is. That's going to go left and right. Set that third one as a plus. It's already a plus. Boom. We're good. Set that third one with a times. And then up here, We're going to set that second one with a times. And then over here, we're going to set that first one with a times. Plus, plus. This was, this was actually times plus plus. This would be setting the second one to plus. And this would be setting the second one to times. They'll give you times times plus. And then splitting this one off. Split this one off. This one off. You're going to set that third one as a plus. That gives you this. You're going to set that third one as a times. That gives you this. That third one's going to get set to a plus. That gives us times plus plus here. Third one gets set to a times. That gives us times plus times. That third one gets set to a plus. That's times times plus. That third one gets set to a times. That gives you times times times. And that is 1, 2, 3, 4, 5, 6, 7, 8, 9. What? 1, 2, 3, 4, 5, 6, 7, 8. It's 8. 8. 1, 2, 3, 4, 5, 6, 7, 8. Like it should be. So I'm like really confused why I'm not seeing 8 results here. It's leaving early. You know what I should do? I should do this. I think that's the same. Is that not the same? Is that not the same? I'm still only seeing 3 though. I'm still only seeing 3 outputs. Why? Why? I'm doing the same thing. Am I not? I mean, is this not the same thing effectively? I should be seeing 8. Huh. Yeah, I think that was the same thing. What if I just, I mean, they are being called. I think it's because it's early breaking. Those are the same way, right? Hmm. Okay, that's because we're leaving early. So we're getting 8. Perfect. So it's there. We're leaving early somehow. Well, that shouldn't be bad. So you just want to leave as soon as you find the right answer. So but that causes it to leave early too. Which isn't bad, like I said, but which isn't bad. Let's see if I get a different answer. Dang it, I'm never going to be able to see what I... I don't remember what I outputted earlier. Crap. Who knows? It was like in the 400s. Like 400 billion or some crap like that. I think that's what it was. Is that what it was? This is the same, right? This is the same. This should work. Let's do it again. I think that's what I did earlier. Yeah, this answer is too low. Okay. That's what we did earlier. Do you think I'm overflowing? No. I don't think I'm overflowing. Let's look at some of these numbers. Wait. Wait. Don't you want to add up... Oh, yeah. Okay. Yeah, you add up the test values. I don't think any of those are, like, gonna overflow along. I don't think so. Damn, it's a lot of them. I feel like a long should suffice. I feel like a long should be fine. Maybe I read it wrong. Am I evaluating correctly? Why is it not working? This, I think this should work. Check combos. Come on, man. Return, evaluate. Yes, that seems right. Crap. Must be the same, right? Yeah. Man. Doesn't help that I'm passing the sample 3749. I know I'm doing something wrong. Hmm. I think this is not working right. Yep, it's gonna be gross. Well, it's gonna be a list of lists of characters. I just want to finish this. Actually, you don't even need to do that. Oh. What's it mad at? Oh. Come on. Yeah, this is gonna be way slower, but... Length 1. No, none of them are. Actually, some of them are length 1. No. What? What? What's happening here? What the heck? That is not right. How is that happening? Okay, that's right, actually. But that's not... I don't know how that's happening. How's that third one happening? How's that happening? What? What in the world? Six? Yeah, that's not right. Oh, it should be 6. But what? It's getting past... How is that happening? Oh, you know what? Yep, that's what it is. Okay. Yeah, you want to clear combos. Still not getting cleared. Three, 7, 4, 9. That's the same number as earlier. What am I doing wrong? I really don't know what I'm doing wrong. Crap. Yeah. That's right, dude. Maybe this part's not right. My answer is too low. So there's some that I'm not getting. Right? My answer was too low. Yeah, that's the same answer I had earlier. Crap. Definitely the same answer, though. And we're getting the right number of combos, right? Like, for this one, I should get 2 times 2 times 2. For this one, I should get 8 combinations. I think if I'm getting the right... So I should get 8 right here. Let's check that again. They should all be powers of 2. Yeah. For sure. This one should be 8. So we're getting the right number of combos. I think we're doing the combos right. Maybe we are not evaluating correctly. There's no way it's overflowing. We could be overflowing. Could we be overflowing? I don't think so. Let's try... Like, can you have a number that's too big? Will it tell you? Yeah, it would tell me. Won't tell you if you have overflows, though. Do you think I'm overflowing? There's no way. I definitely don't have to use big integer, dude. I think a long should be fine. None of these numbers are that big, but if you multiply a bunch of those together, could be. Could be overflowing. But my answer is too low, so there's some that I'm saying aren't possible, but are possible. I'm not using an... Using ints. I don't need that anymore. Oops. Oh. Oh my gosh. I'm such a goofball. It's gonna be big, dude. I think it's probably been that the whole time. Probably the last 30 minutes. Let's make sure we're getting the right sample. Yeah, I think I've been overflowing. Yeah, I was overflowing for sure. Dang it. I should have noticed that that was suspiciously small. I'm going to change this back right now. I kind of went crazy for a second and did some goofy stuff here. Don't need to do that. You can totally do what you were doing earlier. Make this a Boolean. Yeah. Equals target. And then same thing here. Because this is faster, actually. I was definitely overflowing that whole time. Yeah, you don't need to do this. Crap. And yep, don't need that anymore. All right. Make sure we get that same answer there. Yes. I was overflowing the whole time. Didn't pay attention to where I was using integer. The engineers seem concerned the total calibration result you gave them is nowhere close to being within safety tolerance. Just then you spot your mistake. Some well-hidden elephants holding a third type of operator. Okay. The concatenation operator combines the digits from its left and right inputs into a single number. And we could change this. We could go if for loop. For and I, we'll say j equals 0. Or we could say for operator, honestly. For char operator. Operators or ops. Ops dot or operators dot set operator. Yep, just like that. And I can pass those in here. And I can get rid of them up here. And then when I call check combos, I'll put them up here. Char ops. Just pass ops here. Yeah, pass the ops here. Sure. And so this is part 1. So we're going to pass new char. This will just have the plus and the star. Is it literally the same exact problem? Yeah, it's the same exact problem. So we're going to... I'm going to rename this. Or I'm actually gonna, yeah. String data. Char ops. And then I'm going to copy all this. And I'm going to call it what are we summing up again? Possible sum and it's going to need string data and the char array of ops. And then up here I just call possible sum. Data. Yeah, data and ops. Wait, yeah, you can get rid of this now. Because part 1 is going to pass. New char. New charp. Well, this part 2 is nice and easy. Watch me spend another 2 hours on it. And then part 2 is going to be the same thing. Just with that third operator. And then I'll need to go down there and actually implement this operator's functionality. Oh, it can't be a character now. Well, I'll show you this. Yeah, I don't need to. I don't need to do that. Yeah, I can just leave it like that. This is part 2. Let's make a test for part 2. Part 2. Part 2, and the expected output is this. Got our new operator. We just gotta implement. Just gotta implement that operator now. Huh. Dang it. Plus else, this is going to get tricky here. Result is going to equal long dot parse long dot string result operand. Like that, right? Okie dokie. Let's run the test. Nice and easy. Let's just double check. Up. So get the same answer for the first one. Let's make sure our sample. Yep, that looks right. See, I knew they were going to add a third operator. I knew it. I would have been done so much faster if I'd paid attention to, you know, the possibility of overflowing. I mean, I kind of did. I went through and changed everything to long, except for the thing at the very end. Yeah, what the heck? Sum plus equals. Yeah, I didn't change this. I didn't change this to an integer. Oh well. We finished it, and it's pretty fast too. It's not even slow. It's not even slow. With the recursive permutation thing. Not too bad. Yeah, I really don't see a better way to do this right now. I mean, you could get fancier with this. This is kind of a slow operation right here. But as far as like time complexity goes, I think this is it. All right. Thanks for